Good day, class. This is our um, fifth lecture on or I would say this is almost like the part of Module 5 already. No? Only very few lectures to go, and that we would conclude the semester already. Now, this topic is on planning the whole farm systems, and uh, we will discuss another type of budgeting. We call it sorry, allocational budgeting. And then with this allocational budgeting, our primary analytical tool will be linear programming. That's the simplified linear programming. Now, as we all know, according to Poncetlin of Poncetlin, Johor, the news are not good. We must start from fresh. That means to say, knowing from past performance, the update, the current performance is not good. So we must plan out for a better future for a particular farm business operation. So planning, therefore, is a prerequisite for starting up anew or fresh start. So there are two main types of whole farm planning. One is agronomic, the other is physical farm planning. Okay. Now, in physical farm planning, you also have provisions for physical based production activities and also structuring farm service matrix, irrigation, etc. No? Even the type of crop to be planted. No? So that is what we mean physical planning. Maybe the farm layout you're going to change. Maybe the kind of uh, intercropping that you need to change. Maybe the market also can be part of physical planning. In agronomic planning, planning methods are determined first by the type of whole farm systems under consideration. Okay, this involves comparative, careful selection of best planning with objectives of either profit maximization or cost minimization. Okay, so there are two dimensions of whole farm planning. One is short term. Of course, the other one is long term. Okay. In short term, you might be interested to select the best mix of uh, short term crops, livestock production, etc. No? This is common among Asian farms. And then long term planning, no? Long term planning is required in selecting those production activities that are having a longer lifespan, extending over several phases, long term horizon, entire horizon. There is even some kind of like annual or some kind of like more than 10 years, no? It could be 100 years, in fact, no? For comparative budgeting. No? Now, both short-term and long-term planning is required when the problem is to determine the mix of either different crops like corn, citronella, cassava, or other crops. No? The agronomic requirement of the new crops of the crop has to be strongly taken into account. So that means either long-term or short-term, the agronomic requirement is very important. Either short or long-term production planning combined with long-term farm planning. The planning emphasis is often farm development rather than current production. So there is always a an objective when we do farm planning. Either what are the objectives? Either profit maximization or cost minimization. The beauty of that objective is that if you find one, the the shadow result of that is the other one. We call it in linear programming language that the duality theorem. Okay, duality. So there is a dual and there is a primal. That means if you solve for the primal, the opposite of that is the dual. The beauty is that you only have to solve for one, and then you get the other one already in that particular linear programming convention. Okay, general planning objectives and procedures. General objectives could be whole farm planning to select from all feasible activities within constraints imposed by available resources. Okay, so when we have planning, there are always resource constraints, market constraints. There are, for example, services constraints and several other constraints put into play so that at the end of the day you will get what is the optimal farm plan. Okay, in other words, we call this constraint as the limiting factor. Okay, land could be a limiting factor. Carabao power or Mondays could be labor could be a limiting factor or several other factors. Okay, we put them all together and simultaneously solve for the optimal farm plan. As always, the first general step in this type of planning is specify the problem. So what is the problem? Okay, then after you start solving the problem with the objectives of being able to solve the problem. Okay, like for example, this one sample of a base table for whole farm planning. Okay, the planning objectives could be maximization of net cash income, and then these are the no, these are the different for example, resources, land, water, feed, and other things. And then you have the various crops that you are considering. That means to say these are the different activities. Okay, each different resource can will have a different requirement per activity. Okay, an explicit or acknowledged planning objectives could either be maximization of net cash income or food production, optimal food production. A listing of all feasible activities by which the objective might be achieved, a unit activity budgets which show the inputs required per unit each activity, the input output coefficient of each activity, and the standardized unit of each activity. Okay? So first you have the objectives, and then we list down the different activities, and then because you have the what you have the different activities. When we say activities, these are various crops you are trying to consider, and then you have the resource, limiting resource, just like this one in the table. Okay, these are the different activities, the different crops. Okay, and then you have there, and then these are the resources. Okay, these are the resources. So each of that must be taken into consideration. But the explicit or acknowledged objective must be either maximization or net cash income or minimization. Then each activity must also correspond to a budget of like what is the required number of units per activity according to the resource. Okay, that means it will already become the coefficient of that activity. Just like this one. Okay, you have for land. What is the coefficient of land for different crops? So you have 8 units. You set aside 1 unit for soybean, 1 unit for paddy rice, and then for water, that is you have to have 3 units. Okay, for paddy, and then for feeds you have 5 units for cows. Okay, pretty simple. Now this will now become the coefficient. Okay, this will now become the coefficient according to this limiting factor. Okay, now this is now the objective activity output. That means this is the what? This is uh, the objective maximization of cash income 5, and then you have there 12 for cows. Okay, as part of this activity budgets, a quantification of net activity output in a form by which possible contributions to achieve the planning objective can be measured. A list of a possible of available resource and other factors which might constrain or limit the levels to which each of the activities can be brought into the plan. Okay? List of resources and other factors with corresponding coefficient per activity. Very, very, very important. No? Now, just like this one, these are the list of possible activity, these are the limiting resource, and then there are coefficient units. Okay. Then, type of constraints could either be ano, uh, objectively based on material resource constraint. Malay usa nga constraint, no? Or it could be objectively based on non-material resource constraint, such as market, such as production quota, okay, such as labor. It could be availability of labor. Objectively based on material resource, non-material resource. It could also be based on structural constraints, okay, predetermined kind of plan, constrained with the available land or the terrain, something like that. Subjectively or objectively based on consistency constraints. Okay, the family's broad goals are not specified earlier. Okay, so let's go to that was the whole farm planning. But let's go to now. Let's go now to allocational budgeting. Okay, because part of farm plan you also have budgeting. After making the plan, you have to allocate, find for the optimal allocation. We call it allocational budgeting. So, allocation budgeting is the simplest of the three whole farm planning methods, also the easiest and cheapest to apply. There are three operating criteria. One is gross margin per unit of land, gross margin per unit operating capital, and gross margin per unit operating labor. Okay? There are uh, these are the different operating criteria. Maximizing of gross margin per unit of land, gross margin per unit of operating capital. It is most relevant to measure the resource, productivity, and activity performance. Objectives such as subsistence or food production may be more important for farm household, not well linked to market. Kung subsistence, pwede gapon, no? Now, six steps in allocational budgeting. First is determine the most appropriate planning objective. Ideally, this would be done in participatory consultative fashion with the farm family. Determine the appropriate planning period. That's number two. Okay, is it for wet season or for dry season? Number three, identify all possible or feasible final product generating the resource generating activities. Okay. What are the feasible final product? Activities considered could be those that have been operating on a subject farm in the past, or new or adjusted version of this. No? Now, number four step, quantify its activity by a unit budget. Note that for resource allocation purposes, it is not sorry, it is not necessary to know the cash gross margin of any mandatory activity. Uh, the plan is for the other is for other than GM generating reasons. Sorry. Now, the fifth step is define the list, the planning constraint. Define the list of the planning constraint. Note that the labor relates to, or labor as a constraint relates to family labor. There is no hired in that particular example. Okay, you can also use hired labor if no, but here we are consider non-hired labor. Oh, sorry. Formulate the farm production plan. Labor constraint again relates to farm family labor. Okay. Now, using gross margin per unit operating capital, this planning criterion is based on assumption that operating capital is the most limiting resource. Okay, that is if we use gross margin per unit operating capital. If we use gross margin per unit labor, that is also on the assumption that labor is the limiting resource. Okay, so yeah, this is already given. No? Now, for this time, we need to apply allocational budgeting in the concept of linear programming. Okay, linear programming is an allocation budgeting tool used to identify the optimal allocation plan for farm enterprise. Linear programming, or LP, consists of more than two variables cannot be handled effectively by graphical method. Hence, the simplex and other forms of LP algorithm is applicable. Okay, so we will use more than two variables, so it cannot be solved manually. Okay, so linear programming as a tool in allocation budgeting has the following assumption. Okay, number one assumption to take note of this is additivity. The total amount of resource needed is equal to the sum of all of the amount of resource used in its activity. So that is always additivity, no? Uh, Implies no interaction or across activity. Okay? If it is used for soybean, that one is dedicated to soybean. If it is used for cow, that one is dedicated for dairy cattle. Okay? So that is the first assumption. The second assumption is divisibility. Okay, divisibility. Each factor can be to be used or commodity to be produced should be quantities capable of being divided finitely or infinitely. Meaning, fractional quantities are allowed. Okay, because uh, there are times that we need to plan for integer. This is integer programming is separate or different from linear programming because in integer programming you cannot allow divisibility of resource. Like for example, number of trees. How will you account for 0.53? Number of persons. How will you account for 0.75 person? No, that is. But in this, where you need to use, for example, labor, you need to, for example, use uh, feeds or irrigation, you can apply this divisibility or continuity factor assumption. The other one is non-negativity or decision variables. That means all resource to be used are available. You cannot plan for something that is not present. It is non-negativity. That means to say it's greater than zero. So you cannot plan for something that is not existing. And then the other one is finiteness of the activities and resource restriction. If the activities are finite or infinite, then it won't permit computation or optimization. Okay? Ang unang yung assumption dyan is scarcity. If scarcity does not apply in your plan because you have abundant source of many things, why will you plan in the first place? So why will you economize? Why will you plan for optimal? Because anyway, if you need something, it will just be available. But the finiteness is very important assumption. Linearity of input-output coefficient are assumed constant. Okay? That means if instant or constant returns to scale, CRS, if the slope is zero point 0.5, or that means the rate of increase is 0.5, as you double, it will really follow the rate of rate of increase. That means assumed to be constant ang input-output coefficient. Okay. Another assumption, single valued expectation, homogeneity, okay? Optimization, appropriate objective function is rather max or min, okay? Optimization, optimization could mean maximization of profit or minimization of cost, okay? The other one is proportionality of activity level to resources. You see, the assumption here is for those of you who has some background on economics, the assumption here, if you do linear programming, the assumption here among inputs and output relation, sorry, the assumption here is CRS or constant returns to scale, constant resource productivity. So that is the no. Now, in linear programming, we need to apply to be able to understand better. We need to apply the LP algorithm or simplex algorithm. There are three stages of the solution. One is problem identification, then I have problem solving, and solution interpretation. Okay, so identify the problem, solve the problem, and interpret the solution. Okay, just like for example this one. This is a standard matrix notation of an LP model where the equation is maximize Z equals to C transpose X, where C is a row vector and X is a column vector. So C transpose X is this one, C transpose, because it's already a transpose, it should be a column. And then you have here a row vector, okay, a row vector of the different activities or resource, the different resource rather. Okay. Subject to, okay, A x less than or equal to the coefficient, which is beta or B. So this is a standard matrix notation of a linear programming problem. Okay, expressing it in terms of equation, you have that, no? These are the different coefficients. These are the different activities must be less than or equal to uh, B, which is a column vector. Okay, so if we use, say for example, actually the program is written on a matrix notation inside the program, but when the matrix expands to a very so many variables already and expands to uh, maybe 30 or 40 columns and rows, it will no longer be, it will be very difficult to solve it manually. The quickest way is to compute it using the computer program. We call it, we have a specific computer program that we need to use. Okay. Now, in linear programming, I'm going to advance this material to you as our illustrative problem for linear programming. Okay, illustrative problem. I'll just read this problem to you and dichotomize or uh, we will simplify what is given for better understanding, and then afterwards we solve the problem. So this is the story of the illustrative problem. The Himaya Farm in Barangay Liluan, Ormoc City is a diversified crop and aquaculture enterprise. Okay? Due to competition and limited resource available, It wanted to know the optimum use of critical production factors to maximize profit in its corn, vegetable, upland rice, and peanut operation. On a monthly average, farm targets to get as much as 1372 or 1,372 pesos for corn, that is gross margin, and then you have 1,219 gross revenue again for vegetable, 1,005 for upland rice, and 4,000 for peanuts. Total land area available is 5 hectares. Okay? With the current allocation of 1 hectare for each crop, so 1 hectare for each crop, labor allocation are 1.42 for corn, and then 1.87 for vegetable, and 1.92 for upland rice, and of course 2.64 for peanut. The maximum labor available is 16 months. Okay. Currently, also there is available animal for 10 animal man days allocated, or animal months allocated, 1.45 for corn, 1.27 for upland rice, and so on for peanuts also. Current production of peanut is only 0.93, okay, tons. Market can only absorb up to zero point 0.5. Okay. So, in order to maximize profit, how should these factors be allocated among the different crops? Okay. That is the problem. So, himay-himayo na to ang mga given. First, the crop enterprise to be optimized. You have corn, vegetable, upland rice, peanut. So corn, we assume X1, X2 for vegetable, X3 for peanuts, with corresponding gross margin, okay, or gross profit. Available resource, limiting resource, you have land, labor, carabao months, and market, which can only absorb 500 kilos. Okay. The objective is maximization of gross margin. Sorry. So these are what is given in the problem. If you take a look at the story of the problem. So, crop allocation per resource, you have land, 1 hectare, corn, 1 hectare, and then labor, 1.42, 1.87, and 1.9 for upland rice. Carabao, and so on, market, 0.98 yun, market for peanuts, for land, or for market, 0.98 for land. Then, you have what? Given all these constraints, we plot, tabulate the data. Okay? So you will see you have land, labor, carabao, and then you have market. Remember, market has this 0.9, okay, 0.9 hectares. 0.9 hectares for peanut. And then that, because the market can only absorb 500 kilos. Okay? So, gross revenue or profit per allocation should be 1372, 1,219, and so on for like all the different crops or activities. Remember, the crops now are considered activities. Now, the column for land, labor, and carabao, for example, these are all resources, limiting resource. Okay. Now, formulating the problem, we also express that mathematically. Okay. We express that mathematically. So, we write the problem in a mathematical expression. So, you have here, mathematically, the problem is maximize Z. Z is for gross margin. 1372 X1, 1219 X2, 1523 X3, and 4874 X4. Okay? That is the objective function. Subject to land, x1, x2 plus x3 plus x4 less than or equal to 5. Okay? Diba? 5 hectares na available nga land. Labor, 1.22 x1 and so on, then plus 2.64 x4. And labor has only 16.5 man-months or, yeah, man-days. And then Carabao has 1.45 x1 and so on, plus 1.45 x4 less than or equal to 10 animal months. Okay. So the market is 0.98 for peanut, uh, less than or equal to zero point 0.5. Then you have here x1, x2, x3, x4 must be greater than or equal to 0. Why is that? That is the non-negativity assumption. Okay? You cannot, as I said, plan out for something not available. It should be it should be physically available. Okay. So with that, we follow the algorithm. But I'm going to tell you, as of this time, what are the steps in going through with the, because we will do it step by step. I know you already have this in your 203 or yeah, in your management science, but this is a different application in agriculture. Then we will see how these things would also be understood by us, agribusiness. There are four steps. Step zero is determine the starting basic feasible solution. This sets up the initial simplex tableau or table. And then step one, convert inequalities to equations by introducing a slack variable. Diba? Tama ba? This one, these are all inequalities. Okay? That means less than or equal to 16.5. That means napay sobra na. Napay sobra na. Less than good or equal. So, napay sobra. We call it, ang sobra na, we call it the slack variable. Okay? Slack variable. Then, step two, select an entering variable using the optimality condition. And then, stop if there isn't any. The column under this variable is our pivot column. The one with the highest Cj minus Zj value. That is the final solution. So that the table, it is x4. The table, it is x4. This one. Ano ba ito? Yes, this one. It is x4. Okay, that one. Then, step three, select the living variable using the feasibility condition. Computing the resource ratio is needed to accomplish this resource ratio. We will have that in our succeeding lecture. It is computed by dividing the solution column by the corresponding pivot column. Okay? Solution column by the corresponding pivot column. Then, these are the initial computation that we have done. Okay, just like this one. After adding in the slack variable here, we will start for computing the resource ratio. Okay, of that pivot column. Okay, and then we choose. Okay, we choose the column X4 as pivot column because it is the column with the highest CJ value, ZJ value. Also S4 as the pivot equation because it is corresponding to the limiting resource. Okay, step 4, in 2 steps, compute the pivot equation or identify the pivot equation. Then the step 4 is compute for the new equation. Please take note of these 4 different steps. I'm just going to read this with you, but we will apply this, we will implement this step by step in how we solve the problem. Okay? Please take note, balikan na ninyo para ma-master ninyo ang solution. Okay? So, with that note, we will start our lecture here because the actual step-by-step solution an explanation, I will do it this coming Sunday. Okay? It's just so bad that I have a bad cough this time. My nose is closing. I cannot speak very well. So my throat also is itchy. So I need to stop at this point. At least the the qua the qualitative part, the what the uh, less than analytical, or even the descriptive part rather, is done. Now next meeting we will discuss the the rigors of the solution. Hopefully, mahuman by Sunday, tanan sa linear programming. Then I will give you a problem set after that, and then we will see each other in the final. But we still have lecture, maybe one or two sessions more. You know? Because after that, we will have the 212 as the next subject. Okay? So with that note, I would like to say thank you for listening, and thank you for being patient in really understanding my kind of lecture this time because of my colds. No, I'm slight colds this time. I cannot really stay speaking for a long time. So thank you and have a good day.